Hello, welcome to the next part of module 5. We have the gamma function. Now the gamma function is written in this form: gamma of n equals integration from 0 to infinity e power minus x times x power n minus 1 for n greater than 0. Properties of gamma function: gamma of 1 is 1. Gamma of n can be written as gamma n minus 1 times gamma of n minus 1. So gamma of n plus 1 equals n times gamma of n. If n is a positive integer, then gamma of n plus 1 is n factorial. If n is a positive fraction, so this is integer, this is fraction, then I can say gamma of n is n minus 1, n minus 2, n minus 3 all the way till n minus r into gamma of n minus r for the values n minus r greater than 0. So if I say this is 5 by 4, I will take it 5 by 4 minus 1 becomes 1 by 4 times gamma of 1 by 4. Beta of m comma n, this is relation between gamma and beta. Beta of m comma n is gamma of m times gamma of n upon gamma of m plus n. Gamma of half is root of pi, and gamma of n times gamma of 1 minus n. You can write it as pi by sine of n pi. Here's the question: show gamma of n equals integration from 0 to 1 log of 1 by x n minus 1 dx to the power n minus 1 dx for all n greater than 0 using gamma function. So we know gamma of n can be written in this form: e power minus x times x power n minus 1 dx from 0 to infinity. Then we say let x equals log of 1 by y. Log, we are taking the term in the log from denominator to numerator, so we get a minus sign outside. That means my y, I can convert it to e power minus x. I just shift the log to the other side, and dy becomes minus e power minus x dx. As x approaches 0, y approaches 1, x approaches infinity, y approaches 0. We have integration from 1 to 0 minus log y to the power n minus 1 minus dy, because we have e power minus x dx over here, so then we just take it e power minus x dx becomes minus dy. Integration from 0 to 1, so again we are swapping these places, and that's how we get over here. So then this minus and this minus will cancel out. This minus of log y stays, but we are switching from numerator to denominator, so a new minus is generated which cancels out. So at the end we achieve integration from 0 to 1 log of 1 by x to the power n minus 1 dx. Next question: evaluate x power 5 times 1 minus x the whole cube using beta gamma functions. So now this is clearly of the form beta of m comma n. Beta of m comma n can be written as integration from 0 to 1 x power m minus 1 1 minus x power n minus 1 dx. So over here we can say m minus 1 equals 5, m is 6, n minus 1 equals 3, n equals 4. So beta of 6 comma 4 is going to be equal to this. We know beta of m comma n is equal to gamma of m times gamma of n by gamma of n plus n using the beta and gamma relation. So m is 6, n is 4, that we substitute over here. Now since this is it's an integer, we say gamma of n plus 1 equals n factorial. So this becomes 5 factorial, this becomes 3 factorial, this becomes 6 plus 4 which is 10, which becomes 9 factorial. On solving it, 1 by 504. Moving on, evaluate integration from 0 to 2 x times 8 minus x cube the whole power 1 by 3 dx. Now this is not directly in the beta form, because for the beta form firstly we need 1 minus x raised to the power, and we need integration from 0 to 1. There are two changes we have to make. To make those changes, we take let x cube equals 8y, x I can write it as 2 root 3y, taking a derivative from here we get 3x squared dx equals 8 dy, and now x I know from here, so that I substitute over here. I get 2 square becomes 4, 4 times 3 becomes 12, and this becomes cube root of y the whole squared, dx equals 8 dy. Dx I can write it as 2 by 3, so this 8 by 12 becomes 2 by 3, y power minus 2 by 3 dy. For x approaches 0, y approaches 0, x approaches 2, y approaches 1. So then I can take my I am calling it this. I substitute these values in I and I get this particular equation. On simplifying the equation a bit here, 1 by 3 so it becomes 2, and on simplifying it a bit, I'll get it of this form: integration from 0 to 1, y power minus 1 by 3, 1 minus y power 1 by 3 dy. Now this I can compare it with the beta function x power m minus 1, 1 minus x power n minus 1 dx. I get m as 2 by 3, I get n as 4 by 3. This becomes 8 by 3 beta this becomes 8 by 3, beta of 2 by 3 comma 4 by 3. Using the beta gamma relation, I get over here gamma of 2 by 3 times gamma of 4 by 3 upon gamma of 2 by 3 plus 4 by 3, which is 2. Now, since this is n minus r is not going to be less than 0, so I can take n minus 1, 4 by 3 minus 1, gamma of 4 by 3 minus 1. Now, over here I'll get 1 by 3, and this will become, this will also become 1 by 3. Gamma of 2 I can write it as 1 factorial, which becomes 1. This 1 by 3 comes out here, and this becomes gamma of 1 by 3. Now, gamma of 1 by 3 can write it as gamma of 2 by 3 times 1 minus 2 by 3. So 1 by 3 I multiply with 8 by 3. So I get gamma of n times gamma of 1 minus n equals pi by sine of n pi. I get it in that form. I simplify it a bit, I'll get this answer. Evaluate integration from 0 to pi by 2 sine to the power 7 theta d theta. The next question is integration from 0 to pi by 2 sine 7 theta d theta. Evaluate using a beta function. So now we can write beta function in this form using sine theta and cos theta. And then we just compare it over here. Since cos theta term is not there, we take it cos theta power 0 d theta. Compare it, we get the value of m and n, beta 4 comma half, gamma, then we use the beta gamma relation. Gamma of half is root of pi, but we don't need that because we've got 3 factorial times, and these gamma of half will cancel based on 9 by 2 over here. So 9 by 2 minus 1, 9 by 2 minus 2, 9 by 2 minus 3, 9 by 2 minus 4 gives you half gamma of half. On a bit of simplification, you will get the answer 16 by 35. The next question is, show integration from 0 to 1 xy by root of 1 minus x power 4 dx times integration from 0 to 1 dx by root of 1 minus x power 4 equals pi by 4. So we split this into two parts. We call this part integration 1, we call this part integration 2. Now we have to prove I1 into I2 is pi by 4. I1 is equal to this. We let x square equals sine theta, x is root of sine theta. We simplify to get dx, and then we convert the limits. Then we substitute. So now we have sine theta power half times cos theta power 0 d theta. Again using a beta function property, integration from 0 to pi by 2, sine of 2 theta to the power 2m minus 1 times cos theta to the power 2n minus 1 d theta. We get values of m and n that we substituted over here in the beta gamma relation. Gamma of half, as we said, is root pi, that we use over here. And then we simplify, we get this answer. Next we integrate I2. Again same thing, we take x square as sine theta. In the denominator we will get cos theta. We substitute the dx as cos theta by root of sine theta d theta, and the half comes out. We simplify a bit, again we use the same method. We will get root of pi by 4, pi power 1 by 4, gamma of 1 by 4 upon gamma of 3 by 4. I1 into I2, here we have the value of I1, and here we get the value of I2. We multiply the two, we get pi by 4 to your answer. Lastly, we have to evaluate x square by log of 1 by x cube dx using the gamma function. Using log of 1 by x is y, we get log x as minus y, x is e power minus y. We take the derivative, we convert the limits, we substitute. So now we have e power minus 3y, y cube dy, but the gamma function is what? E power minus x. So to get in the e power minus x terms, we must take 3y equals t, 3 dy equals dt, and that's how we simplify it a bit. We take 27 out, so we get e power minus t cube dt. This becomes gamma of 4, this is your gamma function, becomes gamma 4, and then gamma 4 we can write it as 3 factorial, and that's how we simplify it and we get the answer.